Hey everyone, thank you for joining us today. My name is Nelson Wong. I'm a principal engineer on Salesforce Communities.
Hi, I'm Sharad, and I work as an architect in the performance engineering team for communities.
So today we're going to talk about developing Lightning components and performant Lightning communities and scalability. And so first of all, our forward-looking statements. So please base your purchasing decisions on what are currently available in our current product offerings. So today we're going to talk about Lightning communities. How many of you have been building, deploying, or looking into using Lightning communities? Great, thank you. So when we talk about Lightning communities provide out-of-the-box solutions for different community use cases, such as customer communities, employee communities, and partner communities. And in the community builder, you can easily drag and drop your components to design and deploy your community pages. And one of the most powerful features in Communities Builder is that you can also build your own components and add your own logic and your own code into the community to customize it to build your own features. With these customization capabilities, one of the most common questions that we get is that how can you build your custom components and custom code that can work seamlessly on the Lightning platform so that it can deliver the performance and scalability that you need for your communities. So today we're going to talk about performance and scalability in communities. So in today's session, we're going to cover a few major topics in performance and scalabilities. We're going to talk about performance best practices. We're going to talk about a tool for Lightning community page optimization. We're going to talk about some coding techniques. We're going to go through a few demos to show you some of the coding techniques to make your community components performant. And lastly, we're going to talk about community scale. So performance best practices. When we talk about Lightning community performance best practices, it's actually something that we need to consider both the web and Lightning development best practices. Because Lightning communities are also websites and they're web pages. So all of the web development best practices for performance and scalability, they also apply to Lightning communities. And in Lightning, we have a pretty unique framework that works in a way that is a single-page app, and it also is a client-side framework, so that a lot of the logic is executed on the client side. So it does have its own unique characteristics, so that you have to pay attention to when you design your communities. So with this in mind, let's talk about some general do's and don'ts for performance best practices. So in Lightning communities, you can build Lightning components for your own use cases. And the best practice for building Lightning components is that you want to keep them as lightweight as possible. So we have seen some components that pack in lots of features in them. And like I mentioned, a lot of the UI logic is being executed on the client side. So they have to be loaded to the client side first. So with that in mind, you might not want to pack so many features in your own component and only use very little of them. Because all this logic is going to be preloaded to the client. That's that. And secondly, you want to set appropriate caching settings for your resources, such as JavaScript, CSS, image files. In Salesforce, in static resources settings, you can set your own different cache settings, like public or private, for your own static resources. So this is, it goes without saying that this is very important for performance. So thirdly, image sizes. So for your images, you might want to make sure you use optimized sizes for the images. So we're mainly talking about file sizes. In a lot of cases, you can deliver the same quality and resolution for your images with better, more optimized compression ratio so that they can have still the best quality and also smaller sizes. So we recommend to use images that are less than 100 KB. Ideally, they would be less than 50 KB as well. And next, CDN is important because talking about caching, if we have the cache as close as to the user as possible, that would be able to deliver the best performance. So we have a program for CDN that's provided for communities. You can go and enable it for your community today. It's in beta currently, but it's fully functional. So feel free to try that out. And so in this session, we're not going to be able to cover all the best practices, but we have a document online. So you can go search for Lightning Component Performance Best Practices, and there you can see a lot more information on this topic. Talking about don'ts. So in web development, oftentimes we use a lot of different third-party libraries to provide different features. But with today's frameworks like Lightning and also more powerful APIs native to the browser, we eliminates a lot of the needs to include these third-party libraries. So including third-party libraries definitely will make your page more heavy because it needs to load more resources. So, so one of the recommendations for best practices is if you use your third-party library for just a small feature or you only use a small portion of the library, please explore other opportunities to implement the same feature without these libraries. So secondly, there are some common performance mistakes where a lot of components are loaded to the client side, but they're not really needed when the page is first shown. So for example, you may have like a tab, you may have like a few tabs on a page, and the first tab is shown at first, and then the other tabs will not be used at first, and you want to lazy load those components. And also maybe you have a button that when you click on it, it shows a pop-up that shows certain UI. You also want to defer and lazy load those components. Because if you load all those tabs and pages and pop-ups all at once, it's basically gonna make your client code much bigger, so you have to download all this code upfront to load your page. So that definitely would impact the performance of the first page load. And the last thing is the debug mode in Lightning. So we have seen time to time that some production communities will have the debug mode turned on for Lightning components. And one thing that you might not know is that turning on debug mode not only helps debugging, but it also has a negative impact for performance because it has to download the verbose version of all the code to the client for you to debug. So you might want to make sure that you don't have it on your production communities. So with that, with these best practices, we have also built a tool to help you analyze your community and also apply these best practices. So now Sharad is going to show us.
So Nelson mentioned a lot about, for a Lightning community to be performant, you need to keep in mind web best practices as well as Lightning specific best practices. He called out a few important ones, but if you visit the document, there are a lot more things you need to keep in mind. And as you're developing pages day to day, it's possible that you may miss some of them, you may forget about some of them. So to try and make this process easier, we have built a plugin for Chrome. It's currently for Chrome browser called the Community Page Optimizer. And what it does essentially is it looks at the data. It looks at data from a web best practices view, from a Lightning best practices view, and it tries to identify areas of concern. And I'll shortly do a demo where I'll show this out to you. Other things it does is it provides always-on profiling, so you don't need to do anything special. So if you have it installed and you notice some page is slow, you can right away pull up the data and try to figure out what's going on with it. It integrates closely with Chrome browser dev tools, so you get the power of both of them together. And with the recent release, you can see end-to-end metrics. So for a particular call, you're able to see how much time was spent on the app server, how much on the network, how much on the client, and so on. And the last use is, when you're opening a support case, sometimes, you have an issue where you're seeing slowness. And today, probably, there's some back and forth with support trying to figure out what's the exact reproduction to see the issue, or, sending HAR files over. So this tool includes an export feature that you can attach, and that lets us look at all these metrics locally when we receive the request. So jumping to a demo for it. So let's say this is, I'm going to use this as a test community. I'm just going to try and first use, out of the box Chrome DevTools to try and figure out what's going on with it. Let's go ahead. Right. So Chrome DevTools has a performance tab. You can say start recording to see what happens in detail. And you can see our page is up. The DevTools are recording its data. And you often end up looking at something like this. And to note, right now debug mode is off. So as a result, you see a lot of minified functions. You see a lot of anonymous functions and things like that. But this is what you see. So DevTools gives you a good idea. Okay, this is how my page progressed. It gives you a very deep stack. Like if I try to go to the bottom of the stack, it's huge. But unless you know Lightning very well, and even then you may have some problems trying to figure out what do I do next. I can see time is spent here. Like for example, this thing took 160 milliseconds, but what do I do next? What is causing this, and how can I optimize it? So to try and solve that problem, and this is a problem both for external developers and also for internal developers. So we use these same tools for our performance engineering processes internally. And so we loaded this community, but you don't need to do anything special. Pop it out. The community page optimizer is recording the data, and it has done some analysis and given you a score. So in this case, it says the score is 99%. Now, the thing is, this score is not necessarily an absolute score. The idea is not to compare one page versus another, but this tries to give you or identify areas of opportunity where you could have done things better. So for example, in this case, it goes in, it looks at all the XHR calls made. You can see time spent in actions, database, network, and so on. And as you go down, it tries to give you some recommendations. For example, here it's saying the bottleneck was probably the network. So I'm not sure if it's legible, but it's essentially saying try to optimize the response payload. And that is something that happens is sometimes when you're fetching components from the server, if you're not mindful of the dependencies, you may end up downloading hundreds of components from the server. And so this gives you an indicator of places you want to dig further into. It also shows you how your page was rendered. So your page may have visible content as well as hidden content or out of the fold content. And from a user's perspective, what you want is you want the visible content to come in first. And so this shows you a progress graph. You can go down and see a wireframe as well, which will kind of show you how your page came in. Another thing is around the best practice around how do you prevent a component leak, because component leaks can add up, use up memory, slow your browser down. And so we automatically identify a class of component leaks if they happen. And if you see that, you'll see them listed here. And when you're using it by default, we try to focus on components that you are developing. But if you wanted to, you could also look at, if there are any issues with Salesforce components you're using on the page. So you'll find this checkbox across multiple tabs. And I'm not going to go into each of these in great depth, but it identifies, other issues. Like you're creating components, you're destroying them, but you're never rendering them to the screen. So that is time and resources spent on the client where the user is waiting, but they don't see any visual output from it. Now, there may be cases where this is needed, maybe things like providers and so on, but this helps you, this gives you an idea, oh, maybe I need to look into this component some more. Similarly, if you find components that you have created, but you haven't rendered so far, maybe you're going to render them later, but you have already taken the cost of creating them, which could have been used to show visible content, possibly. And so this, again, helps you, pinpoint some of those things so you can investigate further. If you find that you have components which are being re-rendered a lot, like you just rendered it and now it's again being re-rendered, so there may be an issue with the way you're handling data. Maybe you're doing too many updates, too many sets on your components, things like that. And so we help you identify some of those. So now moving more towards web best practices, so around large images. So we pull out images and we start flagging them. If we see anything which is larger than 100 KB, we flag it. If it's a JPEG, unfortunately we don't have one here, but if it's a JPEG, in addition to the original image, we'll also show you an optimized image right here. And optimized images could be in times like 90% smaller, and you could just right-click, save it, and use that image going forward. So we do some of that as well. This is, again, more traditional web page analysis, just looking at the weight of the page in terms of total size of the page, number of resources, and so on. Since we have the CDN functionality, for you to be successful with a CDN, just enabling a CDN by itself may not solve your problem if you're not making resources cacheable. So we help you identify, these are the resources. Maybe they're static resources you have uploaded, but you have not made cacheable, and things like that. So this will help you identify, how can you best leverage the CDN once you do enable it. There's the production mode, which Nelson pointed out earlier. And so we just help, if you see it, we flag it so you can go and turn it off. We have a link to the best practice document. So now going back a little to the timeline, right, that we saw earlier with dev tools, you saw a huge stack, but you had no idea what's going on in there. Now this is looking at the same thing, but now we are showing you key Lightning metrics. So for example, you can see how long it took to render this particular component, how long it took to create it, and so on. So, you can easily go in, you can quickly find something if you wanted. Let's say I'm interested in seeing what's going on with my force hover. And so as we're using DevTools on a day-to-day basis, what we found was the DevTools search is really hard to use. It's hard to get to exactly what you're looking for. So we enabled our own timeline charts for it. And yes, so here you can get a full view of it. So if you look in here, we have a top panel which shows any network calls which were made during the duration of your page load. You can kind of see here. If you make optimizations or you make changes, like, oh, I now made a action background. Is it really background? You can go in and check over here. You can look at your events, so you can see when a particular event happened. For example, get init data or get page component, and you can see the associated component lifecycle data down there. Similarly, if you set any specific timers, timeouts, and so on, we capture those and show those to you as well. Other things to look at in the tool is we try to keep track of how many DOM elements were created as you're using your site, how many Aura components, and so on. And this is another indicator to help you identify if you have a leak. Like if you're loading a page, if you're navigating between two pages back and forth, and you see this chart just continuously increasing, that's an indication you may have a component leak. In order to help you figure out what is leaking, so here we have a tab called Components, and you can load various snapshots. You can see what happened between particular Aura cycles and things like that. Sorry. And so you can see which components were created, which were destroyed, and so it's similar to a Chrome DevTools memory snapshot. But again, instead of going through the entire JavaScript heap and figuring out what that object is, we tell you on a component level what's going on. Another item of interest is the cost tab. And again, you can include all components if you like. And here we try to figure out the total cost that your component has, including any async cost because you deferred some processing and so on. And so this can help you quickly identify, how much client time is taken for this particular component. The The last tab I'm going to go through is the Actions tab, and this is all the actions that took place to load the particular component, particular page, particular app, whatever the case is. And we help you identify opportunities. For example, if things were made storable, they can be cached on the client. So if you needed to do the same action again, you don't need to go to the server. So we help you identify some of these opportunities. And when you read the document, you'll find one of the best practice is to make actions storable. And the last thing that I'm going to show you for now is the export feature. And so you can go export it as a JSON. Let's say test.json. And then once you send it to us, when we reload it, we get the same view that you're seeing here. And so this is available on the Chrome Web Store. So if you went and searched for Community Page Optimizer, if you went and searched for Page Optimizer or Community Page Optimizer, you'll find this tool. So you can install it and use it for your development. So moving on, now Nelson is going to give us a demo of some of the code changes that you can identify using the tool and how you can validate the fixes since then.
Thank you, Sharat. So after seeing this tool, now we're going to go through a few common performance issues and demonstrate how you can make code changes to your components to improve performance for your components. So these are Lightning component performance coding techniques. Today, we're going to go through 3 examples. First is component lazy loading, like I mentioned earlier. You don't want to front load all your components to the client. That would impact the first page load time. So you want to lazy load. Secondly, you want to minimize some round trips to the server. So because you need to pay attention to how the client communicates with the server when you build Lightning communities. Oftentimes, when you build community components, you make calls to the server to load data or do checks on the server, but you may not be aware of how those communications are taking place and how does it impact the performance for the components. And thirdly, we're going to talk about page navigation. So like we mentioned, communities are single-page apps in Lightning. So page navigation is something that we have optimized when you navigate based on our events instead of reloading the whole page. So we're going to show you how to do that. OK, so let's switch to our demo. So here I have this Capricorn Cafe community. And in this community, I have a products catalog. And let's drill into a product detail page. Oops, it's not being. OK, so about that. Let's do it again. So this is the Capricorn Cafe community. And in here, we have the products catalog. So let me refresh the page to make sure that we don't have anything in cache. So now let's drill into the product detail page. And this is the page that I'm going to demonstrate how to optimize. So loading this page, it takes a second to load the contents. Actually, let me quickly log into this community to demonstrate the logged-in user's experience. So as you see, this page takes a second to load. Let me refresh and try again. Especially the information at the bottom of the page. So how come it takes time to load? Let's pull up the performance optimizer, community page optimizer, and take a look. So my favorite tab is the waterfall tab, where I can see the waterfall of the page load. And you can see in the beginning, this JavaScript file loads. this is mainly starting up the community Lightning single-page app. So we're going to mainly focus on the page content loading after this. So total, it ends about here 3.5 seconds to load this page, which we're going to try to make it faster. So we're going to focus, like I said, we're going to focus on the page content load, and it starts after loading all these JavaScript files. And you can see like these OR XHRs, these are the requests that we make to load page contents. And we're going to try to tackle these requests that are taking a long time. So for instance, this one takes 0.58 seconds to load. Let's see what this request is. When I click on it, on the right-hand side, we can drill into the request and see the details and look at what actions are actually taking place in this request. So I see that this is a get page component action. So what this means is it's getting the components that you configured on this page, and this request basically just loads those components. And now let's switch to the component code and see how this component is designed. So on this page, the product details page, let me go back to show how it looks like one more time. So the product details page has the highlights area where I show the title and the image for the product. And below it, there's a detailed product information. And there's a secondary tab for discussions that shows basically the feed of this product. And one thing I noticed is that at first page load, I don't really need to show the discussions for this product. So how can we defer the loading of the discussion until the user clicks on it? So looking at this component, this is the product details component. Basically, it represents all the information that is shown on this product details page. It has a tab set, and this tab set has two tabs, the product info and discussions. And looking at the discussions tab, it loads this chatter feed for this product. So before we go into how to manage when components are loaded, let's talk about this concept of component dependencies. So on your components CMP file, basically, all the components that are referenced, like in this case, C:product highlights, force chatter, feed, they are dependencies of this page, this component. So when you load this component, basically all the dependencies are going to be loaded at the same time. So they will all be added to that get page component request. So in this case, the force chatter feed is a component on the discussions tab, and it's loaded upfront. And we don't want that, because if we go back to the page optimizer, we see that this takes quite a while, and also it loads, the response is like almost 400 KB. We know that the feed component is a pretty heavy component because it supports various types of feeds and various features in the feed. So the question is, how can we defer and lazy load this feed component? So what I'm going to do is I'm going to comment out this component so that it's not referenced on this page. And instead, I'll dynamically load this component when this tab is being clicked on. So here on this tab, I have registered a onActive event. And it's going to call the activate discussions controller action. So if we go to the controller.js file, and I already have implemented this activate discussions action function. And what I do here is that it first checks whether discussions has been loaded. And if not, it's going to dynamically use $a.create component to create this component on the fly, basically giving the name of the component and the attributes that we need to pass in the component. And on the callback, I'm going to find the discussions tab and set this feed component to the body of the tab, and also set loaded to true for discussions. So now let me go back to initialize the discussion loaded to false so that the component knows that it's not loaded yet and it needs to be dynamically loaded. And now I'm going to refresh this page after the change. You might feel that the content has been loaded more quickly than before. Let me try this again. So now let's take a look at the page optimizer. And actually, I'll clear out the history and refresh this page so that it will record this page load. Now if I refresh and go back to see this request, that is the get page component request. Let me double check. Get page component. And now it's taking much less time. It's taking 0.26 seconds instead of it was almost 0.6 seconds. So, and the download size has been reduced by a lot. It's actually less than 50 KB now. So you can see that the overall page load time also improved. So it ends about here, it becomes around 2.5 seconds. So good, very well. But looking at the page load, I still see the details and the description information loaded with a lag. Let's try that again. And let's see why is that. Let's see if we can improve that as well. So, and you can actually see that in the page optimizer. So with these XXCharts green bars, you can see that these are being made like sequentially. So like making this request and then this request and then this request. So they're being made kind of sequentially one by one. And what we don't want to do is to have this kind of sequential request to server, just like going back and forth, go to the server and then do something on the client and go to the server again and do something on the client again. So what we want to do is try to either batch these requests to server in the one request, or we want to do these requests in parallel instead. So let's take a look at the component code and see what really happens. In this case, it's in the product information below is in this C: product info component. Is underneath the highlights component. So in this component is actually inside this or if block. What it does is that oftentimes we have content on the page where we need to check some conditions or make some run some logic on a server to determine whether we should show it or not. And in this case, it depends on whether the product is in inventory to show the product details. And initially, has inventory is initialized to false. And what it does is on initialization of this component, it's going to make an action call to the server to check whether this product is in inventory. So when it comes back, it will set has inventory to true if it's successful. So once it checks whether it's in inventory on the server, then it will know that whether product info should be shown. But let me try to explain what happens here. So what this or if means, and especially setting the initial condition to false, is that it's going to block the creation of the content inside this or if block. So in this case, this product info component is not going to be created upfront. And also inside this component, the product info component is a record view for this product record. And this record view also needs to make its own request to server to get the data to show on the record view. So essentially, it's going to make one call to check inventory in server. When it comes back, we create this product info, and again, it will make a call to server to get the data to show on this component. So now what I'm going to do is I'm going to change this logic so that it's not going to be wrapped around an or if block. So what I'm going to do instead is that I'm going to use CSS to hide this component before we check the inventory. So with this, if condition is this CSS class, if it has inventory, then we use SLDS show class, which means show whatever content is in this element. SLDS hide is to hide this element. So with CSS, we're not actually blocking the creation of the component inside. So they're all loaded at the same time, all created at the same time. It's just hidden using CSS. So with that, I'm going to go back to the page. And again, I'm going to clear out, refresh it again. So as you can see, the description shows up much more quickly with much less of a lag compared to before. So let's see what happens here, the page optimizer. So it has inventory, is this call to server, and it happens pretty much in parallel as the record view, which gets the data to show in this component. So there's no longer this back and forth from the server to client and making calls back to the server. So overall, the page load time now becomes around 2 seconds. So that further improves the page load time. So one last demo I want to show is that page navigation. A lot of times when we do page navigation, it takes a while. And in this case, I have real products. So when I click on it, it reloads the whole page. And very quickly, here we have an href for this anchor that goes to product catalog. And instead of doing that, I'm going to do on click and use our events instead. Use our navigate to URL event instead to do navigation. So let's quickly show that. So as you can see, there's no more full page reload, and it's much faster than before. So with that, I'm going to hand it back to Sharat. Oh, sure. So basically, it's using the navigate to URL events and giving it the URL to navigate to, which is under the communities route. So if you go to the communities builder, you'll be able to find out the route information. Okay.
Yeah, and we'll be around after this session in case you have more questions. So moving on. The last topic that we just have time for right now is community scale. And often, how much can your community scale? How many users can it support? This depends on a variety of factors, but the key factors are the type of community. Is it a customer community? Is it a partner community? The type of access. Is it unauthenticated or authenticated users who are going to be using it? Traffic patterns, like what is your peak access rate to the site versus sustained and things like that. And also the data shape in terms of the amount of data you have and what you're trying to display on your community. So on this slide, you see some numbers. And I would call out that these are soft limits. So we know that we can scale to these fairly easily. But that doesn't mean we cannot scale further. We can scale higher, but the main thing is we recommend you use the process called out at the end, the large data volume deal support request, so that you can reach out to us and we can help you analyze your use case and recommend the best way to scale to your levels. So for example, if it was 10 million, you need to scale to 20 million. We'll help you analyze it and come up with a recommendation how best to do it. That's all we have for you today. And if you have any questions, I know we are out of time here, but you can reach out to us. We'll be around. And the last thing I want to mention is other interesting communities related tech talks to check out at Dreamforce. Thanks a lot for your time, and I hope you're enjoying Dreamforce.
Thank you.